in this problem we are going to find the first derivative of this given function here, and since it's a quotient, then we're going to need the quotient rule. So here's a real quick recap of the quotient rule. Right, quotient rule says, why don't you take, and we'll call this numerator here, we'll call this numerator f, and my entire denominator down here, all of this stuff down here, we'll call g. Right? So quotient rule says, all right, let's do the derivative of f times g minus f times the derivative of g all over g squared. Okay. The other thing we're going to need to figure out what the derivative of this quotient is to keep in mind that let's say you have f is the tangent of x, that the derivative of tangent, something else you have to memorize and learn, that the derivative of tangent is secant squared x, right? Or secant x quantity squared, either way you look at it. Okay, so I think we've got everything we need here to figure out what the derivative of this is. Here goes. All right, quotient rule in action. All right, so give me the derivative, right? Quotient rule says give me the derivative of the numerator, that's f prime. So the derivative of tangent x is simply secant squared x, there we go. All right, times g, times, in this case g is my entire denominator, so I'm going to wrap that in parentheses as well. Okay, minus, right, so this minus sign is this minus sign right here, minus, now give me f, well f is just my numerator, tan x, okay, times g prime, so times the derivative of the denominator. Well, this is just a polynomial here, so I've got the derivative of 1 is simply 0, I'm not even going to bother writing that, plus the derivative of tangent, well we know that that's secant squared, so over here I've got secant squared x. Okay, so there's my f prime g minus f g prime, and this is all over my g, which is 1 plus tan x quantity squared. Right, so it's all over my g squared. All right, well we can clean this up a little bit more. I hope you see that in this numerator right here, do you see that I've got secant squared times both of these things? So really it's just the distributive property that's being done there. So let me clean that up. And since it's just tan x times secant squared x, I really don't need the parentheses over here either. So let me write my numerator this way. Alright, so let me write my numerator this way. I've got secant squared x times 1. That's just secant squared x. And secant squared x times tan x, well that is secant squared x tan x. Okay, so I just use the distributive property there, don't need the parentheses anymore, minus, all right, this product over here, which you can write it this way if you want, or I'm just going to move them around. I'm going to put the secant squared x first and then put the tan x second. And I'm doing that because, do you see in the denominator now, oh, sorry, in the numerator now, in the numerator up here, my denominator just stayed the same, right? That didn't change any, okay? But you see in the numerator now that I've got two terms that are opposites. So I got this guy here and this guy here, and since one of them is positive and the other one's negative, they cancel each other out. Okay? They're completely gone. So my final answer for this derivative here, let me scoot this down, my final answer for this derivative is, in the numerator I have a secant squared x, and in my denominator I have quantity 1 plus tan x squared. I think I have enough time. Let me try another problem. Alright, let's do another one here. How about in this second problem, let's make up another one here that looks like this. Right. If I tell you, or if the book tells us that y is equal to, how about 5 sine x over 7 minus 2 sine x, and we want to know what's the derivative of that, right? The first derivative of that. Well, again, this is a quotient rule problem, and so we'll call our entire numerator f, and we'll call our entire denominator g. Okay? So the Quotient rule says give me the derivative of f. All right, give me the derivative of that numerator, which is 5 sine f. Well, the derivative of 5 sine f is 5 cosine x. Okay, and then that times g, which is my entire denominator, so I'll wrap that in parentheses, minus 2 sine x. Okay, minus, and again, this is for the quotient rule, so minus f, which is my numerator right now, right, times the derivative of g, times the derivative of g. So times the derivative of all this stuff. Well, derivative of 7 is just 0. That's a constant. And the derivative of negative 2 sine x is negative 2 cosine x, right? So I've got negative 2 cosine x. There we go. So that was my f right there. That was my g prime. This was my this was my f prime. This was my g. There we go. That looks better. This was my f prime, or f rather, and there's my g prime. I'm all screwed up. Okay. All over g squared, which is just my quantity 7 minus 2 sine x squared. Okay. So to clean up the numerator a little bit more, do you see that I need to distribute, just like I did in that first example we worked out, I need to distribute this parentheses times 7 and this parentheses times 2 sine x. Okay, this over here is just a product, and look, I've got two negatives being multiplied together, so I'm really going to have a positive term coming up over here. All right, so let's clean up the numerator a little bit. I've got 5 cosine x times 7 is 35 cosine x. All right, I've got 5 cosine x times a negative 2 sine x, which is a negative 10 cosine x sine x. Remember what we said over here, right? A negative times a negative is a positive, and 5 times 2 is a 10, so this is plus 10 sine x cosine x all over the same denominator quantity 7 minus 2 sine x squared, right? All that is being squared. Okay, and just like in the previous example, do you see that these two terms right here, this guy and this guy, are exactly the same, except their signs are opposite, right? So I've got a positive 10 sine x cosine x, a negative 10 cosine sine x. Same thing. Again, can you move sine x and cosine around so that it looks like this term? Sure. Right? This is all a product anyways. These are all being multiplied together. And the commutative property says as long as you're multiplying, you can commute them. So these guys are opposites and they cross each other out. My final answer is the numerator has a 35 cosine x, and my denominator is quantity 7 minus 2 sine x squared. There you go. Hope that helps.